The recent case of Airmax Technologies illustrates how the informal appeal procedure can be used to defend an SR&ED claim. In this case, the taxpayer, Airmax Technologies, was an installer of HVAC, heating and ventilation equipment. During prior years, they identified limitations in the standard practice technologies to distribute heat evenly in multi-story townhomes. They identified various objectives through the year on improving sound reduction, static pressure, and efficiencies in the existing system. Throughout 2007 and 2008, they claimed SR&ED work. The first was work for a quieter air diffuser, which was accepted by the Canada Revenue Agency. In addition to that, they had activities with respect to changing the duct system to make it more noise compliant and integrating a foreign source boiler as well as an electric motor. The Canada Revenue Agency denied these activities on the basis they were routine engineering. This case then brought up two issues. Number one, what work is eligible for SR&ED? And number two, what are the effects of the informal appeal procedure? We're going to deal with each issue separately. On the issue of eligibility, the judge first looked at the definition of SR&ED in the Income Tax Act and understood that it includes a catch and release concept, where a series of activities are included, paragraphs A to C, all your design and testing, and any activities which don't correlate with the resolution of a pre-stated technology problem, for instance, marketing or quality control activities, would be excluded. In this case, the judge felt that the evidence showed departures from standard practice in that they identified limits of ductwork in existing townhouses and unconventional heat sources. This then created uncertainties or problems by going outside the box. These problems related to best methods to mitigate noise, to choose spacing in relation to efficiencies and the types of systems. As a whole, the judge felt that the work had relevant record keeping and hypothetical solutions. We'll now review the Airmax case using our R&D-based system. If we launch the R&D-based demo, we have a series of sample projects. Number 1201 represents the Airmax case. So what we've outlined is the objectives and how they are departures from standard practice, the related variables of uncertainty, and the activities that were used to address those uncertainties. To review the project at a high level, we'll use something called the Key Criteria Summary. This summary tells us what we did to benchmark the state of existing technologies with respect to internet searches, patents, competitive products, or queries to experts. It then allows us to quantify objectives, whether they be cost, footprint, noise, efficiency ratings, and so forth. These objectives then tend to stack up to create the variables of uncertainty or experimentation. These are the things that could not be answered with our existing standard practice. Examples that are typical to this industry could be a part design, for instance the coil, its shape, depth, and location. This in turn could affect the components themselves, the diffuser versus the ducts versus the boiler versus the electric motors, their layout and spacing. The diffuser design itself could be affected by the shape, aspiration rate, locations, just to name a few. Once these key variables are identified, the related activities to address and conclude on the optimal combination of those components is the eligible SR&ED work. Ideally, what we want to do for each fiscal year is identify the activities, the related cost, and the method of experimentation. Typically, there's three main methods: analysis or simulation, process trials, which tend to take longer, and lastly, physical prototypes with revisions, which tend to take the longest. Ideally, we compare any results from these activities to our objectives, and most importantly, identify which of the variables we've identified we've made conclusions upon. In the case of Airmax, the diffuser work was accepted by the CRA, but the related work on the ducts and the furnaces were challenged and ultimately won. The issues in question here would be the basis to support the advancement in the technology and thus support the claim. If you do similar work, we welcome you to review the full project description within the R&D base layout or within the newsletter.